So now today I'll discuss some important questions from 1.3. So the question number 3 is, you are given a set A here whose members are 1, 2. This is counted as one member. So 3 and 4. So remember there are 4 members. 1, 2, this, and then 5. You know every member is separated by comma here. So it has 4 members. I repeat, 1, 2, 3, 4. There's one member and then 5. Now first question is, question number 1 is 3, 4. This is one set. A is a subset of A. Now you know subset means every member of this must be present in this. So this set has 2 members, 3 and 4. Where A has no such members, you can see that 3 independently is not there, 4 independently is not there. So this is obviously false. Remember, A should have like this members. This is just for your information. It should have something, then 3 and then 4. It should have like this. But such thing is not there in A. There you have in a curly braces 3, 4. So this is counted as one object. So this is false. Second part is 3, 4. 3, 4 belongs to A. Now belongs to means what? This member should be present in A. So which is already there. You know this 3, 4 is already in A. So this is true. I repeat, belongs to means this is one object that should be present in A. So which is already present in this. So therefore this would be true. Then next one, if I go to third, so there in a set you have 3, 4. So this is one set whose one object is this. This is one object present in this set. E is a subset of A. So here you have one object which is 3, 4, which is also there in that set A. So this is true. I repeat, subset means every member of this set should be present in A. Now this set has how many members? One member, that is in a curly bracket 3, 4, which is already present in this. So every member of this set is present in A. Therefore this is true. Fourth one, if I go to fourth, 1 belongs to A. So 1 is already present in A. So this is true. If I go to fifth one, 1 is a subset of A. Now this is obviously false. Why? Because here one member and here one set. Now subset relation is not for member and set. Subset relation is for 2 sets. So this is naturally false. This is never true. 1 is a member. If you are given like this, then true. In a singleton set, E is a subset of A. If you are given like this, then this is true. Because in that case, this set has one member which is already present in this. But you are not given like this. You are given just 1, not singleton 1. Sixth one, if I go, 1, 2, 5 is a subset of A. Now 1 is a member of A, 2 is a member of A, 5 is also a member of A. So obviously this is true. Next one, 8, if I go to this, 1, 2, 5 belongs to A. Now here in this set you have 1 which is present in A, 2 is present, sorry, this is for belongs to. Now this means this is one object here. When you have belongs to symbol, that means this is one object. Now if it is true, then such object must be present in A. But 1, 2, 5, this entirely one object is not present in A. So this is false. If you have like this just for information. 1, 2, 5 belongs to, you can have like this. Here for example 1, then you can have like this 1, 2, 5 and some member, for example 6, like this. So this member is entirely present here in this set, so then belongs to symbol is true. Here this member is not present in this, therefore this is false. 9th, if I go, sorry, this was 6th. Now if I go to 7th, sorry, this was 7th. If I go to 8th here, so in 8th you have 1, 2, 3 subset of A. That means one member 1, it should be present here, which is true. 2 is present in this, 2 is also present in this. Now 3 is present in this, but 3 is not present in this, so this is false. Reason, 3 is not present in A, remember. 3 should be present in A. Okay, if I go to 9th, 5 belongs to A. Now this is obviously false. Now we must have realized 5 is a subset of this, but it never belongs to A in this case. It is true if you have like this, if A has such members 5, then 1, then 2, something like this. So here 5 is a member of A, but here what are the members of A? That is 1, 2, 3, 4 and 5. In this 5 is not present. This 5 is not present in A, so therefore this is false. 10th, which is always true, you know, empty set is a subset of every set, so this is true. This is always true. Null set is always a subset of every set. And what about 11th? If I go to 11th, here you have singleton 5, subset of A. Now in this set you have one object 5, but which is not present in A. A doesn't contain 5, so this is again false. So next, fourth question is write down all subsets of given set. So the first one, you know it, singleton set. So you want to list all subsets here. Subsets. You know this set has one member, so total number of subsets is 2 raised to 1, which is 2. So one is 5 and the other one is set itself. One more, I'll go to 4th because the other two we already did. Here 5. Now this is a null set, remember. This is a null set. So total number of elements is 0 here. So total number of subsets is 2 raised to 0, which is 1. So subsets will be here just 1, which is 5 itself. Okay. Total number of elements again 0. So total number of subsets is 2 raised to 0, which is 1. So which is 5 itself. Now next question, 5th one. You are given A equals to 5, that is null set. Then you are asked number of elements in P of A. Now what is P of A? That's a power set of A. You know, this is called a power set. So I already answered here. This is the null set. So number of subsets equals to 2 raised to number of elements in this, which is 0, that is 1. So therefore P of A has only one element. That is what I'm trying to tell you is this, that is P of A equals to all subset of this, which is 5 alone. So it's like this. Now next question, question number 6. You want to write following sets as an interval. So here x such that x belongs to R all real numbers, -4 less than x less than or equal to 6. What's the meaning of this? Every number starting from -4 to 6. So in form of interval, open minus 4 to close 6. So all such number, if this is minus 4, if this is 6, open minus 4 to close 6. So minus 4 is excluded, but 6 is included here, remember. This is open close interval. Next, if I go to second question, all real numbers x such that minus 12 less than x minus 10. So this is nothing but minus 12 is excluded, minus 10 is excluded. So this is open interval minus 12 to minus 10. This is open interval. So it's like this. If this is minus 12 and this is minus 10, then all numbers between these two, remember. All numbers between these two numbers are not included here. That's why we write by this round parenthesis. In square bracket, 6 is included, minus 4 is excluded. Next question, question number 7. There you are asked in form of write in set builder form. Set builder form. So you want to do reverse of what you did in previous question. So the first question is open interval minus 3 comma 0. So in a set all x such that x is a real number and x is between minus 3 and 0. Strict sign, less than 0, less than minus 3. If I go to second one, close interval 6 comma 12. That is every number from 6 to 12, including 6 and 12. X such that x belongs to R, where x is from 6 to 12. So this says that the 6 and 12 are included here. This 6, this is 12. So every number from 6 to 12, including 6 and 12, remember. So we have this. Then next is, for example, one more. If I take third one, open minus 6 to close 12. So open close interval. So all real numbers x such that x is greater than 6 and less than or equal to 12. So if you notice, what is difference between these two? Here 6 is not included, 12 is included. So in these two, there is one number extra here, 6, which is not present in this. So you can just note, we note that this open 6 close 12 is a subset of 6 close to 6 12 close interval 6 to 12. There is one number extra 6 which is not present in this. Okay, now 8th question, it's about universal set. Question number 8. Write the universal set. The one set you are given, set of right triangles, and the other one, that is set of isosceles triangles. So you can imagine universal set here, U, capital U, equals to set of all triangles. Set of all triangles. Right. So if I take set of all triangles in a plane, then it would include all right triangles as well as isosceles triangle. If you recall, universal set means the biggest set for a given problem. So here I have considered set of all triangles, which include right triangles, isosceles triangles. So this is a universal set. So now we discuss important part of sets, which are known as operations on sets. Operations on sets. On numbers, you know this operations. On numbers, you know addition, subtraction, multiplication and division. These are the 4 operations. These are the standard 4 operations on numbers. This we know. So if you have 2 numbers, you know how to add them, how to subtract them, how to multiply and how to divide. Now same way we have some operations here on sets. So operations on sets, we have this 4 standard operations. One is called union, intersection, difference, and complement. This is read as union. This is here. This is read as union. This is called intersection. This is called difference. And this is called complement here. These are the standard 4 operations on sets. One is union, the other one is intersection, then difference, and then complement. So if you take 2 sets, let A and B be 2 sets, let A and B be 2 sets, then the first one, their union. So this is read as A union B. How do we read this? A union B, which is set of all elements which are either in A or in B. So this is called union. So therefore A union B represented by this all X, such that either X is in A or in B. So every member which is in A or B referred as union. Now we have some diagrams for this. They are called the Venn diagrams. Venn diagrams for sets. So what we do in a Venn diagram, we represent rectangle by universal set. So we have some universal set here. Rectangle represent universal set. So this is a universal set here. Sets are usually represented by writing the circle. So this is one set A, this is the other set B. That means these are the subsets of universal set U, A, B. Now members which are present in A, that is here, or members which are present in this B. So this is read as this entire shaded portion is read as A union B. So this is A union B. In short, you combine the members of A and B without repetition. That's the union. I repeat, A union B is a set of all members which are in A or in B. So you are just combining. To take union means you are combining the members. So in a Venn diagram it is this. What is the Venn diagram? It is just a representation of a set in form of diagrams. Universal set is always represented by drawing a rectangle. Within this rectangle, sets are represented by circles normally, not necessary always. So these are the members of A, these are the members of B. In a union, you are combining. So this shaded portion represents A union B. So for example, let's take A equals to, I'll take 1, 2, 3, 4 for example. B equals to, let me take 2, 3, 4, 6, 7. So therefore A union B would be here, all members either in A or B. So 1, 2, 3, 4. Now 2, 3, 4 are already present, so you cannot repeat. So now 6 and 7. So every member of A union B is either in A or in B. 1 is in A, 2 is either in A or B. So you are just combining. Remember, that's union. One more. If I have like this, let's take P equals to this set minus 1, 2, 3, 4, and Q equals to another set. Let's take 4, 6, 7, 8, 9. So in that case, what is A union B? That is again combine the members. So minus 1, 2, 3, 4. Now 4 already written. So 6, 7, 8, 9. You are just combining members of both the sets. That's union. I hope this is clear. Now next operation is intersection. The precise meaning of intersection means you take the common elements in both. Intersection means common elements. So A intersection B is all x such that x is in A and x is in B. Common means and. All elements which are in A as well as in B, right? Elements, that is elements in A and in B. That's common elements which we represent by and. So and represent intersection, where or represent union. So in a Venn diagram, if I see this, if I go back to Venn diagram of this, so I'll represent again a rectangle here, that is universal set U. Then set A, for example, set B here. So if I take one member here which is in A but not in B, if I take another member here which is in B but not in A, so this portion represent all elements which are present in A. So this shaded portion is in A as well as it is also in B. So this common region that is known as A intersection B. A intersection B. So here A intersection B is nothing but all elements which are in A as well as B, common members. For example, let's take set C equals to have this -2, 1, 0, 4. Randomly I have taken one set. D equals to, for example, I have 0, 1, 2, 5, 6. So here C intersection D would be, you just write the common elements. So here one is 1 common, the other one is 0 common. So here intersection is 0, 1. Intersection means all elements which are present in both. That's common element. So 1, 0, 0, 1. So this is A intersection B here. One more, if I take, let's take X equals to this set, 2, 3, 4, 5, and Y equals to another set. I'll take 1, then let me write 6, 7, 8, 9, 10. So you can see that there is no common element. 2, 3, 4, 5, here 1, 6, 7. So here A intersection B is 5. So such sets are said to be disjoint sets. Disjoint sets. When sets are said to be disjoint, if their intersection equals to 5. Like this. In a Venn diagram it looks like this here. If this is universal set here, this is set A here, this is set B here. You can see there is no common portion. So here A intersection B is equal to 5. So such sets are called disjoint sets. Okay. Now next one, which is different sets here. Here different sets. It's like our subtraction operation. So A difference B. This is one different set. This is all elements in A, remember, of A, which are not in B, which are not present in B. So this is sometimes called only A. Members of, I repeat, all elements of A which are not present in B, which is known as A difference B here. A difference B. Similarly, you can write B difference A also. All members of B, remember, which are not present in A. That's called B difference A. It is not our simple subtraction, remember. All members of B which are not in A. This is sometimes called only B. These are the two different sets. So in a Venn diagram, you can represent like this. If this is universal set here, represented by, rectangle. This is a set A. This is a set B, for example. Now, all members of A which are not in B. If I pick up this is of course a member of A, but it is also member of B also. So you cannot take this member. So only this portion. This is called only A portion. This is symbolically A minus B. If you go to this portion, these are the members of B, but not A. If I pick up one member from here, then which is also in A. So only this much portion, this much. This is called B difference A. B difference A, members of B which are not in A. A difference B, members of A but not in B. So these are the two different sets. So for example, let's take set A equals to, I'll take 2, 3, 4. B equals to, I'll take for example 1, 2, 5, 6. C equals to, I'll take one more here, 1, 2, 5, 6, 7, 8 for example. So let me find some different sets. I'll find first A minus B. So all members of A which are not in this. If I take 2 which is present in this, so it cannot be here. 3 which is not present here, 4 which is not present here. So this is 3, 4. I repeat, what is A minus B? Members of A which are not in this. 3 is not in this, so it will come in A minus B. 4 is not in this, so it will come in A minus B. In short, what you have to do, you look at it common and you drop the common, so 3, 4. Then if I find B minus A for example, so in this 2, what are the common? 2. So you drop 2, then you are left with 1, 5 and 6. I repeat, what is B minus A? All members of B which are not in A. 1 is in B but not in A, so 1 will come here. 2 is present in both. 5 is in B but not in A. 6 is in B but not in A. So in short, from this 2, so here B has this member. So B has 1, 2, 5, 6 and A has 2, 3, 4. What I did, I've deleted B. So 1, 5 and 6, these are the members of B minus A. And this was B, this is A here. So what is A minus B? That is just 3, 4. Now next, if I write A minus C for example, so all members of A which are not in C. So look at it common, 1, 2 is common. Okay, so here I suppose you will get the 3, 4. Members of A which are not in C. 2 is present in both. 3 is not there. 4 is also not there. Then what is B minus C, which is interesting? Members of B which are not in C. So 1 is in this, 2 is in this, 5 is in this and 6 into this. So you are left with no members in B. So this will be 5, remember, right? Every member of B is present in C. What is B minus C? All members of B which are not in this, but here every member in this. So if you look at the common of these 2, here members of B are this 1, 2, 5, 6. And members of C are 1, 2, 5, 6, 7, 8. You drop the common, this is common, this is common, this is common, this is common. So you are left with no members in B. So this is 5. Members of B which are not in C, which is 5. Say if I write C minus B for example here. So members of C which are not in B. So you are left with just 7, 8. So here 7, 8. Right. So clearly if you write A minus 5 in general, so it would be obviously A. All members of A which are not in this. Okay, so this is different set. Now next we have a fourth one, which is complement of a set. Complement of a set. So for a given set A, its complement is denoted by this symbol, denoted by a dash, or sometimes a raised to c. This is read as a dash. Now what is a dash? That is all elements of the universal set, that is a rectangle, which are not in a given set. That's called a dash. This is for a single set. All members of the universal set which are not present in the given set, that is other than the members of A, that is called complement of a set. In general, what you are doing basically here, from the complement you are deleting all members of A, that is U minus A in short. A dash is nothing but the universal minus A. From the universal set you drop the members of A, that is from the rectangle you drop the members of the circle. So here Venn diagram would be like this. We take a single set here, so this is the universal set here. This is a set A. Now how we define A dash? All members of the rectangle which are not present in A. So this portion, this is known as A dash, this exterior portion. So this shaded portion is A dash. Right. What is A dash? All members of the rectangle which are not present in the given set. So two things you can note here clearly. Number one, if I combine A, that is this circle, union A dash, to combine means to take the union, and this portion, so what you will get? Entire rectangle, which is universal set. Universal set, this is union. If I combine circle and exterior portion, you will get the entire rectangle, which is universal set. A intersection A dash. Do you have any common in this circle and the shaded portion? No. So answer is 5. This is always true. Right? And one more thing, this is always true. A dash is universal set minus A, remember. So from this you can write this fourth one. What is universal set of complement of the universal set? Which is universal minus universal, which is 5. And fifth one, complement of 5. That is from universal set you drop nothing, so you will get the U, universal set. So these are the 3-4 things regarding complement. Union of set and its complement universal. Intersection of set and its complement is null set. Complement is basically this. Complement of universal set is 5 because it is like this, universal minus universal, so it would be obviously 5. Then complement of 5, it would be universal set. For example, let's take A equals to, I'll take here 1, 2, 3, 4, and universal set equals to 1, 2 up to 10. So then what is A dash? A dash will be from universal set you drop these 4 members. So 5, 6, 7, 8, 9 and 10. From universal set you drop 1, 2, 3, 4. So you are left with this. This is A dash.